Okay, now we spend some time on this because there's always a question on it. First of all, perimeter or circumference of a circle, assume this formula is true. Circumference is equal to 2 times pi times whatever the radius is. Now, just for the moment, let's assume the radius is 1, just for now, but we're going to show that it works no matter what the radius is, okay? 1 instead of r, 1. That means 2 times pi times 1. We can just shorten it to this. This is only when the radius is 1. Circumference, to go around the circle, is 2 times pi, and that's our radius angle. Now keep in mind, radians don't really measure the angle in here. They measure this area here, which is why the circumference is 2 times pi. Times r, but in this case, r is 1. So to go around 1 full time is 2 times pi. Of course, to go around half is just pi. And to go around a quarter is just pi over 2. And we discover that, you know what, all I'm doing here is I'm taking a percentage of the angle and I'm multiplying it by this. For instance, 90 degrees, if I went 90 degrees of the whole 360, that's a quarter. That cancels out here or reduces here, and I get pi over 2. So we discover that this measurement here is always 2 times pi times whatever the radius, or sorry, is always a percentage of the 2 pi. So the shorter it gets, the smaller that is. It becomes more of a percentage. And we end up with this formula. That arc angle, let's get rid of that, is the same as taking the angle, whatever the angle is, that arc area, the red area, is whatever the angle is, theta, times the radius. Now, this is the angle. We use this to measure, and I use this now because if I use A, it's going to get confusing. So we get this formula. You might say, well, how does that work, Peter? Well, I just gave you an example. When that's pi over 2 is the angle, we get pi over 2 times the radius, which is 1 in this case. That's the arc distance. It's pi divided by 2 is that distance here. Let's call radius 1 centimeter. So in centimeters. And you get used to that. You get used to this formula. Now, how do I use that? Let's pretend we have a Ferris wheel now. Let's pretend, now this is the angular momentum, angular velocity part. Let's pretend we have a Ferris wheel, and let's pretend that Ferris wheel is not 1. Let's pretend it's 5. And we're going to forget all about this arc here. Okay? And this angle. And we're going to pretend we're on the Ferris wheel at the bottom. And its radius is 5, so of course its height is 10. So you might get Ferris wheels where they tell you the height is 10, but really, a Ferris wheel with a height of 10 is a radius of 5. It's the radius we want to figure out. You can always use radius is equal to the diameter divided by 2. So you can always have that here too, diameter divided by 2 instead of radius. But we figured out the radius, it's 5. So let's figure out, if I get on the bottom here, and I go all the way around, let's figure out how far I went on the outside of that circle. Well, the outside of that circle is the circumference. It's 2 times pi, and in this case, the radius is 5. It's 10 pi. 10 times pi, and let's call it, say that 5 is 5 meters. 10 times pi meters. Or, if I were to use an exact number, it would be roughly 31.415 meters, let's say. So I've traveled that distance. So that's the important part. That is distance. And as we learned before, velocity is simply distance over a time. Okay? So that means if I did that distance in 1 minute, or 1 minute, and they wanted to know my speed, and you have to be careful here. If they want to know the velocity in meters per second, and it takes me 1 minute to go around, we have to convert that to seconds because they want it in meters per second. 1 meter is equal to 60 seconds. Well, we know the distance I went around is 31.415, and the time is 60. So I take that and I just divide that. And that's how we were doing that speed before, 31.14. Got it wrong, 31.415. And divide it by 60. 0.5. So I'm going 0.523 meters per second on the outside of that circle. Okay, so let's just stop and think, how did I get this? Well, I got that distance there by taking 2 times pi times the radius, and then whatever time they gave me and whatever conditions, that's how I came to it. So we get this here, but we don't always, times the radius, which was 5, like that. But we don't always travel that much. For instance, they might tell you, I only traveled a quarter of the distance, which is pi over 2 times 5. So then suddenly you get 5 pi divided by 2, and then you figure that out and divide it by the time, and you get a different speed. This time's a little slower because it took me 60 seconds only to go to a quarter. I'm not moving as quickly. But ultimately, the velocity formula becomes this. Velocity is going to be whatever angle we're dealing with times the radius divided by time. You might say, Peter, how can it be the angle? Well, remember when we went around 2, the full circle was 2 pi times the 5. It doesn't really matter what the radius is. So let's just keep it as that. And when I go around 90 degrees, it's pi over 2 times the radius. That's then divided by time. So you get all these things where essentially I'm always taking whatever my angle is in radians and multiplying it by the radius to get time. So it all depends what I do. If for instance, my Ferris wheel goes around 3 times, right? 3 times, it's 3 in 60 seconds. It's 3 times 2 pi times r divided by time. Then I would fill it in. It's this. This becomes 30 pi times time. As we discovered before, 10 pi is 31.45. So 3 times that one is like 94.2 something meters per meters, and the time was 60. And that ends up being roughly 1.53 meters per second. So it drastically changed when my Ferris wheel went around 3 times in 60 seconds. It went 3 times as fast. Well, I can always just save myself time by using this formula instead of figuring out all the nitpicky stuff down here. But I want you to understand what they're measuring. I also want you to understand this. Let's pretend we have a Ferris wheel that's this high inside a Ferris wheel that's this high, like that. And let's pretend they both spin. They both start at the bottom, and they both spin at the same time. Let's pretend this inner circle one has a radius of 5. And let's pretend this outer circle one, I'll use it as green, has a radius of 10. Let's pretend Natalie gets on, she climbs a little staircase, and she gets on here. And let's pretend I'll use her as red. Okay, Natalie gets on right here. And let's pretend Lazaro gets on the bigger one here. And you're both spinning. You're both matching each other. You're both here, and then here, and then here, and then here. Well, let's say it goes around once in 60 seconds again. And let's look at the speed of Natalie versus the speed of, or the velocity of Natalie, the angular velocity of Natalie versus the angular velocity of Lazaro. Well, Natalie has the same formula. It's going to be 2 times pi times the radius divided by the time. Lazarus is also 2 times pi times the radius divided by the same time, except it's clear. So this is Natalie's velocity in red and Lazarus' velocity in green. Well, it's clear the only difference is the radius. Natalie's is 5 and Lazarus is 10. Let's look at these two numbers. Well, 5 times 2 here is 10 pi. And Lazarus, 2 times 10 is 20 pi. Since the top part measures the distance, it's clear that Lazarus travels twice the distance that Natalie does in the same time. In other words, this ends up being 31.415, and this ends up being 62.830 per 60 seconds. This number is going to be roughly 0.5, and this number is going to be roughly 1. Let's see what they are. So Natalie's is 5 times 2 times pi divided by, or hit equals, then divide by 60. You have to hit equals, otherwise you can mess it up. This is Natalie's speed in meters per second, if assuming it's 5 meters and 60 seconds. We'll just put it there. Meters per second. Lazarus, I'm going to predict, is going to be 1.04 meters per second. The same, double the speed. Let's see. 20 is his is 10 times 2 times pi equals divided by 60. Oh, look at that. Exactly as predicted. We would actually have to round his up a little different. We'd have to round his up to 5 because there's a 7 after. So we see, oh, twice the radius, twice the speed. And that is angular velocity. Lazarus is spinning around out here a lot faster than Natalie, even though as they go around, they're on the same spot, like they can look at each other. They're on the same spot of their respective wheels. But it's clear that Lazarus is traveling a much bigger distance in the same time than Natalie. By the way, Natalie, you'll feel more dizzy than Lazarus will, because as you spin, as you spin in a smaller and smaller circle, you get more and more nauseous. And the bigger the circle, the less nauseous you are, even though you're going fast. Now, Lazarus is going to feel a lot more wind in his face than you are, because it feels to him like he's going a lot faster. And guess what? As we keep going this, if we had a 15-meter Ferris wheel, the person on the 15 meters is going to go 3 times your speed. They're going to go roughly 1.6, 1.5 meters per second. They're moving a lot faster. And it's all a ratio of the radiuses. And that is angular velocity. So we end up getting this formula. Your angular velocity is going to be the angle times the radius divided by the time it takes you to go that radius arc, whatever that angle arc. And keep in mind, this is where people get confused. We're used to thinking of angles. We're used to thinking of angles as the measurement here. But radians measures outside here. It's sort of a distance measurement. And we do it because it's much more useful and mathematically it can be applied to formulas like the speed on the outer circle. If we use 90 degrees here, we would have to use SOHCAHTOA and all sorts of extra calculations to figure out this distance here. What radians allows us to do is come up with a simple formula for that distance. And that is how you measure angular velocity. Now, keep in mind, a lot of questions will tell you different information. They'll tell you Natalie is moving 60 meters per second. Her Ferris wheel is takes 60 meters per second, and her Ferris wheel takes 1 minute to go around, which is 60 seconds. And it'll say, what's the radius? Well, in this case, we have the velocity over here instead of looking for the radius. The velocity is given to us, 60 meters per second. We also know that her angle to go one full circle is 2 pi. We don't know the radius, but we do know the time. It was 1 minute. So we're trying to get to r. First thing we do, right now r is, the whole thing is being divided by 60. So we multiply both sides by 60. We get 360 meters per second is equal to 2 pi times r. Then we're trying to get r all alone, so we're going to divide both sides by 2 pi. Which means the radius of this wheel is 360 divided by 2 pi. The 2 can go into 360. If your teacher wants you to leave it in pi radians, you would just say this, the radius is equal to 180 divided by pi radians. Like that. If she wanted you to calculate it in meters, she said, I want it in meters, you would then take 180 and you would divide it by pi. Remember that pi is just a number. And you get this, the radius of this giant Ferris wheel is 57.3 meters. It's huge, which makes sense because 60 meters per second is a hell of a lot faster than the calculation we did a little while ago. So since we know it takes her one full circle, 2 pi, to get around, we discover that. We could also just have a formula for the radius in these questions. It's going to be the angular velocity multiplied by the time divided by the angle in question. In this case, the angle was one full circle, but if they told you she did 3 circles, it would be 3 times 2 pi. If it said you covered that in a quarter circle, the angle is quarters, 90 degrees, pi over 2. So you can see that we don't need the numbers in there. They might give you a question where they tell you the radius. They tell you the radius is 10. They might tell you Natalie is moving 2 meters per second. Her angular velocity is 2 meters per second. They might say, how much time does it take to go once around? Well, once around is an angle of 2 pi. So you can fill all this in. The angular velocity is 2 meters per second. The angle she went around is 2 pi. The radius is 10. The time is what we don't know. And the time, unfortunately, in this case, is on the denominator. So we have to multiply it on both sides to get it to the numerator. It gets over here. Time times 2 meters. We just divide both sides by 2. The 2 and the 2 cancel out. And we're left with, if they told meters per second, 10 pi seconds. Or, if I want to calculate out, 31.415 seconds. In this case, it took that much time to go once around. If your speed was 2 meters per second and the Ferris wheel had a radius of 10 meters or 20 meters tall. They can give an angle where a situation where they don't tell you the angle. They can say, okay, well, your angular velocity is 1 meter per second. The radius, they tell you, is 5 meters. They tell you it takes you 5 seconds to go from point A to point B. 10 seconds, let's say. They say, okay, well, you get on here and you end up here. How much distance is that? Based on 1 meters per second, the radius is 5 meters, and it took you 10 seconds to go from here to here. Well, it's the same thing. You plug in what you know. I know my velocity is 1 meters per second. I don't know my angle, but I know my radius is 5, and I know my time is 10. Multiply both sides by 10. Divide both sides by 5. The unit should be left over as radians. 10 divided by 2 is 5, is 2. 10 divided by 5 is 2. So that means my angle is 2 radians. Well, I know a full circle is now. Oh, here's an interesting question. What if I said, what percentage of the circle is that? Did you of the radius of the circumference? Did you go? Well, I know that circumference. I know that this radius was 5 meters. I went 2 radians. I know the full circumference is 2 times pi times the radian, which is 5. So 10 pi. I know that 10 times pi is 31.415. I also know that I only went 2, that's radians. I also know that I only went 2 radians. 2 divided by 31.415 times 100 will give me my percentage. That's a tougher one, right? Times 100. So I only went 6.63% of the circle. I only went a tiny bit, 6%. Only went. You really started off at the bottom and you went right to there, tiny bit, because the full radian circle is 31 and you only went 2. So there's all sorts of things that they can ask and measure, but it's really all comes down to that. Now, I hope you take the time to understand this, because when you understand it, figuring it out is a lot easier than memorizing formulas.